Hello, my name is Matthew, and I have the privilege of being paid by Ericsson to make the world a better place through open source, and for that I am grateful. I would like to show you a feature that was in tracecompass for a very long time, and that I believe is not well enough known. Let's say that you're tracing several nodes, several servers that are communicating together. Well, their clocks are going to skew, they're going to diverge a bit. So here, we're going to start by making a tracing project. I'm going to call this one Django Benchmark. Now, I'm going to import into here from Matthew, TMG traces. There should be Django right here. If we open it up, you're going to see three different kernel traces. These are operating system level kernel traces, and all three of them are together. And we made an experiment called Django Benchmark. Let's open it up. Now we're going to start by observing the histogram on the bottom. You can see that there is red and blue. So we have events from two given traces. And you can see that the spikes kind of correspond, which means that they're probably time aligned. That's great. Uh-oh. This green one, it's about 8 seconds off. How can we possibly correlate the data? So we're going to zoom out. We'll see here, same thing. Your data from one, your data from a second, your data from a third. This is a problem. But it is quite a solved problem. You see, if we look in our statistics, at our event types, we do have some network events. And when we have these, you can go here by right-clicking on the experiment itself, and you can synchronize your traces. And let's say that we're going to put the client as the reference trace. Please observe the histogram down here once I click Finish. It's doing the synchronization operation. And it closed the trace. But that's fine. Notice now that your number of traces in your experiment went up. You have several that are appended with a underscore. These are the ones that are time offset. And here, the Django benchmark, if we open it up, you will see that all three traces now are time synchronized. The algorithm used is a very powerful one, and it can handle stuff like clock skew, and even if the clock changes its frequency halfway through due to thermal drift or something. So now if we look around, you'll see that all the traces are aligned, and you'll even see our nice executor pool as we've shown earlier. This is a very common pattern. It's loading up nicely, and there we go. The three final spikes are there. Double click. It's all there. Now let's say that we go to Python here. I will open up the critical view. I will put it here for now. And if we follow Python, which is the process that launches everything, we will build ourselves a critical path that will span across nodes that have been time correlated. I, for one, think that is really cool. I hope this is one of the many tools. Here we go. I hope this is one of the many tools within the tracecompass and tracing tool belt that will cause a shift in your perception and make it, when there's a bug, that instead of having the reaction, oh no, there's a bug, I want to have people go, oh yes, I'm going to learn something new. I'm going to learn what happened that's wrong. Thank you very much, and happy tracing.